Video 8.1, Day 1, Variation Functions. Please write down the essential question. How do I solve problems using direct and joint variation? Why do we learn this? Well, you can use variation functions to determine how many people are needed to complete a task, such as building a home in a given time. So, we have studied many types of linear functions, and a special type of linear function is called a direct variation. And basically, what that means is it's a relationship between two variables, x and y, that can be written in the form y equals k times x. So I'm going to highlight this right now, where k cannot equal 0. In this relationship, k is the constant of variation. For the equation y equals x, the wording is y varies directly as x. A direct variation equation is a linear equation, basically in the form y equals mx plus b, but in this case, b is going to be 0. The y-intercept is 0, and the constant of variation, k, is going to be our slope. Because b equals 0, the graph of a direct variation always passes through the origin, because since we're going to always start at 0, 0, because the y-intercept is 0. Let's do an example. Example number 1. Y varies directly as x. So that's the key. We have to be able to read. Y varies directly as x. They're giving us what y is. They're giving us x. And we're going to write and graph the direct variation function. The key is the wording. Y varies directly as x. Just like that. I'm going to plug in what y is equal to. And I'm going to plug in what x is equal to. And the objective here is we are going to be solving for k. So how do I do that? I divide both sides by 6. 27 divided by 6 is 4.5. That is our constant of variation. And now what we need to do is we can rewrite this as an equation. Y equals 4.5x. Now we're going to have to graph this, and so we're going to do that right now, but first I'm going to put a box around that. In this case, our slope is 4.5, and our y-intercept, like we said, is 0. So we start at 0, 0. Basically, we're going to go up 4.5, 1, 2, 3, 4.5, and over 1. Up 1, 2, 3, 4.5, over 1. Or down 1, 2, 3, 4.5 to the left 1. And 1, 2, 3, 4.5. There we go. And now, if I draw my line, which I sometimes struggle with, I did pretty good actually. Okay. And there we go. There's our graph. We know it's going to go up and to the right because our slope is positive. Helpful hint. If k is positive in a direct variation, the value of y increases as the value of x increases. That's the direct variation. So I like to think of it as this. The faster that I drive to see my parents, I'm going to get there quicker. They're directly related. The faster I drive, the faster I'm going to get there. Now, am I encouraging you to drive fast? No, I'm just trying to give an example of a direct variation. The hotter the sun is, the warmer we feel. Directly related. All right. Example 2, I'm going to save, and we're going to do that in class together. And now we're going to go to joint variation. That is a relationship among 3 variables that can be written in the form y equals kxz. So instead of y equals k times x, the direct variation, it's a joint variation. There's more variables involved, where k is the constant of variation. For the equation y equals kxz, again, y varies not directly, but this time y varies jointly as x and z. And the wording, again, is important to keep in mind. There it is. Y varies jointly. The phrases y varies directly as x and y is directly proportional to x have the same meaning. Here is our next example. Example 3. The volume V of a cone varies jointly, there it is, as the area of the base and the height. So first thing I'm going to do is this. Oops, one more thing. Volume. I guess our equation is right there. Volume varies jointly. We need our K with base and height. They're telling us the volume. They're telling us, the base and the height. And we're asked to find B when the volume is 24 pi feet cubed and the height is 9 feet. On these direct variation problems, it's always a 2-step process. We have to find K first using what we're given. So we're given initially that the volume is 12 pi. I don't know K. I know my base is 9 pi. And I know my height is 4. So what I just grabbed are these items: volume, base, height. Volume, base, height. And now I'm going to use them to solve for K. 9 pi times 4, that's 36 pi. I'm going to scroll first here. And I'm going to divide both sides by 36 pi. 12 pi divided by 36 pi, well, the pi's are going to cancel. And if I reduce that, I'm going to get a K value of 1/3. Great. So now I end up with V equals, plug in K, just like we did on the last example. And now I'm going to answer the question. Find B, or in this case, we're really finding this should be an uppercase B, not lowercase b, when the volume is 24 pi and the height is 9. Let's do that. Volume is 24 pi. I want to find base, and my height is 9. So I'm going to do one little thing here. I'm having trouble reading that, so let's fix that really quick. 24, there we go. And just to separate these. So what did we just use? We just grabbed this and this, and we plugged them in. Okay, so now we have, whoops, not that, stay with red. 24 pi is equal to, well, 1/3 times 9, that's 3. And we're solving for B, divide both sides by 3. My pi keeps looking weird. Let's fix that. There we go. So 24 divided by 3 is 8 pi. That is our B. Our units in this case on B is going to be feet squared. So B is going to be 8 pi feet squared. And there we used what we know about joint variation to solve a word problem. Video question, write the direct variation function. And number 2, please write those in your notes.